Okay, so for today, our third day of transformations, we're talking about reflections. So far we've done dilations, where the figure gets bigger or smaller. We've done translations, where the figure slides across the coordinate plane. And now we're doing reflections. A reflection is basically a flip over a line that's called the line of reflection. Each point and its image are the same distance from the line of reflection. The x-axis and the y-axis are common lines of reflection. Those are the only lines of reflection we will use this year. And then reflections result in congruent images. Okay, so if you'll look, here's our original point B, and the image of point B should be the same distance away from the line of reflection. Point C is the same distance away as C prime is from the line of reflection. Same thing with point A is the same distance away as point A prime. Okay? So let's look at these examples. It says triangle ABC with vertices at 1, 6. So that's at 1, 1, 2, 3, 4, 5, 6. There's point A. B is at 8, 3, so 1, 2, 3, 4, 5, 6, 7, 8, and then up 3. And C is at 4, 2, so 1, 2, 3, 4, and up 2. There is point C. So when I connect those points, I get this figure here. And we're going to reflect it over the x-axis. So one thing that Miss Lucky and I and Miss Kelly all like to do is kind of highlight the axis that we're going to flip it over. We're flipping over the x-axis, so I'm going to make sure that I flip this figure over the x-axis. So point A is 1, 2, 3, 4, 5, 6 units away from the line of reflection, so it's got to be 6 units on the other side. 3, 4, 5, 6. That's point A prime. C is 2 units away, so its image will be 2 units away. B is 3 units away, so its image will be 3 units on the other side. So here is the reflected image. So here's the original triangle, this is the reflected. Alright, so A prime is at 1, negative 6. Okay, B prime is at 8, negative 3. C prime is at 4, negative 2. Okay, so we went over the x-axis and we went from 1, 6 to 1, negative 6. We went from 8, 3 to 8, negative 3. And we went from 4, 2 to 4, negative 2. So notice that when we went over the x-axis, the x-coordinate stayed the same. See how 1, the 8, and the 4 all stayed the same, but the 6, the 3, and the 2 all changed signs. It went to negative. Okay? So the y-axis now, we're going to flip JKLM over the y. So first I'm going to plot the points. 2, 1 is right here. This is point J. 4, 7. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7. It's right here. 7, 6. 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5, 6. And 5, 0. 4, 5, and then stay put. So the lines are a little off, but you get the drift. There we go. Alright, and we're going to flip this over the y-axis this time, it says. This one right here. The y-axis goes up and down. So I'm going to flip it from here over to here. So 2 units away, 2 units away. I forgot to label these. This is J, K, 4, 7, J, K, L, and M. So this is J prime. Alright. K is 4 units away, so K prime would be 4 units away on the other side. L is 1, 2, 3, 4, 5, 6, 7 units, so 7 units on the other side. 1, 2, 3, 4, 5, 6, 7. And M is 5 units this way, so I'm going to go 5 units the other way. 1, 2, 3, 4, 5. There's M prime. So this rectangle over here. It's a little sloppy, but you get the drift of it. Right over here, we said when we went over the x-axis, all the x coordinates stayed the same. I'd be willing to bet that over here, since I went over the y-axis, I bet all of the y's are going to stay the same. And I bet all of my first numbers are going to go the opposite. I'm going to make that prediction, and I'm going to say J prime is going to be at -2, and the 1 is going to stay the same. I'm going to say that K is at -4, and the 7 is going to stay the same. I'm going to say that L prime is at -7, and the 6 will stay the same. And M is at -5, and the 0 will stay the same. Let's double check. J prime, -2, 1. K prime, -4, 7. L prime, -7, 6. M prime, -5, 0. Alright? So if we go over the x-axis, the x stays the same and the y becomes negative. If we go over the y-axis, the x goes negative and the y stays the same. So here we're going to go over the x-axis, so my rule is going to be the x stays the same, the y changes sign. I'm going to go ahead and do my points. I'm going to highlight the ones that are going to stay the same. Oops, nope. Did that wrong. The 8, the first numbers are going to stay the same because we went over the x-axis. So that's going to be -8. And this is going to change signs. Now just because it's negative doesn't mean that you leave it negative. This means change the sign. So I'm going to make this a +6. Alright? X stays the same. The 2 changes sign, so I'm going to make that a +2. The R stays the same. This changes signs. I'm going to make it a +1. So when I plot all of these points, P is at -8, 6. So 1, 2, 3, 4, 5, 6, 7, 8. And -6 would be right here. So there's point P. Q is at -5, 2. So that's 1, 2, 3, 4, 5. And down to the 2, -2. And R is at 2, 1. So, excuse me, 2, -1. So over 2, down 1. So that's P, Q, and R. So you get this obtuse triangle. And then I'm going over the x-axis, which is right here. And if I plot these points, -8, 6 would be up here, P prime, and if you'll notice, 6 units below, 6 units above. -5, 2, I'm going to go to the -5 and then up to Q, that's Q prime, and then 2, 1, I'm going to go over 2 and up 1, that's my R prime. So when I connect these, and you can see that you get this mirror image. Alright, the y-axis, that means this time the x is going to go negative, the y will stay the same. So my points, the y is going to stay the same. I'm going to highlight everything that I'm going to leave the same. So that means the 2 is going to change signs, the 3 stays negative. The 4 is going to change signs, the 1 stays negative. The 8 is going to change signs, the 2 stays negative. This is going to change signs, and that's going to go to positive. Alright, and we're going this time over the y-axis is going to serve as our mirror. If I plot all of these points, 2, negative 3 would be right here. That's W. 4, negative 1 would be right here. That's X. 8, negative 2 would be 1, 2, 3, 4, 5, 6, 7, 8, negative 2. So this is Y. This was X. And Z is at 3, negative 7. So 3 and then down to the 7. And that is Z. So you've got this, oops, this figure right here. Okay, and we're going to flip it from here over here. I'm going to use my points here, negative 2, negative 3, 2, negative 3, and you'll see that that's W prime. 2 units away, 2 units away. Negative 4, negative 1, negative 4, negative 1. That's my X prime. Negative 8, negative 2. That is my Y prime. And negative 3, negative 7 goes right here. Is that right? That's 4, right here. That is Z prime. 3 units away, 3 units away. So I connect these points, and it should look like a mirror image of the original. Okay. I'm going to leave this page for you to do independently. It's the same concept. This one you'll flip over the y-axis. This one the x. This one the y. This one the x. This one the x. And this one the y. So same thing on this page. Get some independent practice in class. Plot your original points. You can either make sure that the new points are equidistant from the line of reflection and then get your new points, or you can apply your rule. Remember, if it's the y-axis, that means that the x changes and the y stays the same. If it's the x-axis, that means the x stays the same and the y changes signs. But I'm going to let you do these 6 in class on your own. And then let's, we've already talked about the rule, but if you're flipping or reflecting over the x-axis, what did we say? If it's over the x-axis, that means the x stays the same, the y changes signs. Same thing down here. If you're flipping over the y-axis, that means the x changes signs and the y stays the same. So let's look at this. It says triangle LMN with vertices L is at negative 8, negative 2, negative 3, negative 1, negative 1, negative 8, undergoes a reflection with these new coordinates. We went from negative 8, negative 2 to 8, negative 2. So I'm seeing that The negative 2 stayed the same. 3 to negative 1, negative 3 to negative 1. I'm seeing the negative 1 stayed the same. Here the negative 8 stayed the same. So what I'm seeing is that the y value in every single coordinate pair stayed the same. The y stayed the same. So your rule would be the x is going to change signs. The y is going to stay the same. So the line of reflection is the one that stays the same. The y stayed the same. So the y-axis is the line of reflection. Which pair of points represents a reflection across the x-axis? If it's the x-axis, that means the x stays the same. So here we went from negative 7 to 7. Here we went from 4 to negative 4. Here it's not even the same number, much less the sign. But here the 1 and the 1 stayed the same. This is the one that shows the reflection over the x-axis. And that is this lesson.